Okay, so this is a short example. What I was looking for was something where I could show you what a client looks like when it potentially is a little bit compromised. And one of the schools that I know that has an awful lot of the Dell Latitude E5430 single band laptops, but which has not been visited and not been tuned, is Gov Elementary. And so what I've done is Gov Elementary is also not mapped at the moment. So I've just pulled out the monitor screen uh, for the access points for Gov Elementary, and I was looking through. Um, I first of all found this room 1230, which had 21 clients, but unfortunately, this is near real time. And when I looked at it, I couldn't get any grasp for those clients because they had all recently disassociated, disconnected from the access point. So I went back up to 1216, which is access point 3783C0, and I looked at the clients on it. Yeah. And then I noticed this particular client, which has got quite a lot of data, but is yellow, indicating that there's some problems. And we can see Gov obviously has some dual band because these Wi-Fi 1.2s are connecting on 5 gigahertz. But you can see all of these Wi-Fi zeros, which have a MAC address beginning with 8056F2. They're all on the 2.4 gigahertz band. So I looked at this client, and so I initially looked at the total frame count. And what we can see is that this one was online from quite early on, from about 8:40. But things really started to happen around 9 when we all started to get some traffic. Now these are frames, not kilobits or megabits per second, just frames. A frame can be of a different size. So if we look at the bandwidth, we can see that we ramped up to around about 3 megabits per second. So 3,000 kilobits is 3 megabits, from about 910 to about 920. We're about 940 right now. And we can look at a transmitted bitrate distribution, which is from the access point towards the client. And that generally looks quite healthy, except when you consider that most of the bandwidth was occurring from 910 to 920. And, we hit our 72 for some of them for 16%. We had to drop to 65 for 11%, to 58 for 17, to 52 for 41, to 39 for 10, and even down to 6 point. Well, no, actually, no, that's 26. So things aren't quite perfect there, but they're tolerable. And remember that the bulk of the data is going in the direction from the access point towards the client. And if we look at the received bitrate distribution, now remember we talked about the fact that for power saving we might drop down to 6. But again, if you look at the time when the action was going on, remind you that it's from 910 through to 920. You can see that we're kind of struggling. We're down at 19.5, 26, 39, 52, 58, 65, and a tiny bit of 72. So this is not a really problematic client, but it's like a less than perfect client. And again, I would be more concerned if what we had were big issues going the other way, because the bulk of the data is going from the access point to the client, and therefore this is where airtime is being consumed. And obviously, the faster the transmission can occur, the less problematic the the less problematic the situation is. So for most of this, we were maintaining speeds above 50, and this is a single band client. Or sorry, a single antenna client. So the other thing I will do here is I will check the access point health. So I'll just look at that. We can certainly see that on the 2.4 gigahertz radio, we're seeing some modest levels of interference, but those really aren't that bad. So there's nothing really there that looks particularly worrisome. We're seeing that one thing we are seeing here, if we look at this automatic channel selection protocol neighbor information, we are seeing a neighbor which is on the same channel, channel 6. If you go down here, you can see that the radio details were on channel 6. Another access point which is visible at the level of negative 64 dBm. That's kind of a concern, and that's the problem with Gov. As long as that particular access point doesn't have a lot of clients, then we don't have a problem. But if it did, then we would have a problem. So that access point is 376280. You have to take 15 off of that. If we were to go over to here, Control F, 37628. Actually, we do potentially have a problem here because this particular access point has 12 clients, so that's not good. And that might be the cause of the interference on this particular client. So if we look, we'll see that most of our clients are okay, but a few have a problem. And what it may well be is that those particular clients may well be on the wrong side of the room. They may be closest to the interfering access point and therefore more affected by it. And it's worth at this point looking at the other two clients showing radio issues. Let's look at our radio distributions. This one looks reasonable. This one also looks pretty reasonable. So although it's complaining of radio issues, it doesn't seem to be tremendously impacted by them. And our last one here, which has got a lot of data transmitted, 520 megabytes. So let's open this one up. And you can see, if we look at the bandwidth, that this guy was hitting 6 megabits per second, which is quite fast for wireless. So again, we look at our rates from the access point towards towards the client. Things are pretty good. Let's go the other way. Again, this is not bad. Certainly we are dropping down to 18 for 15%, but most of it looks pretty healthy. Okay, so that was just a video to show you an example of when things can be less than perfect. Unfortunately, as I say, I don't have anything to show you right now where things are really not good at all. But when I get a situation like that, I'll be sure to make a video and to post it. Okay.